Hello everyone, welcome to this Conquer Algorithm series. In this series, I will talk about how to conquer algorithm problems that could be used in the interview. Today, I will talk about using quick select algorithm to solve k's largest element issue. Let's see the question first. We want to find k's largest element. You can check this problem in the LeetCode 215. The problem is find k's largest element in an unsorted array. Note that is the k's largest element in the sorted order, not the k's distinct element. For example, the input is 3, 2, 1, 5, 6, 4, and k equals 2, and the output should be 5. You can use the LeetCode to check this question and solve by yourself. To solve this problem, we have a naive solution that is easy to sort all the array and then select the k's largest number. We can see that only 2 lines of the code can solve this problem. However, when we do the sorting, the computational complexity of this algorithm is logN. It's the same as the sorting algorithm. Can we have an algorithm that is more efficient? Quick select algorithm is used to solve this problem efficiently. It's the same as the quick sort. In the quick sort, we choose one pivot, and then using the pivot to split the whole array into 2 subarrays. That the first subarray is smaller than the pivot, and the second part is larger than the pivot. We split this way until everyone is ordered. That's the quick sort algorithm. Quick select algorithm is similar as quick sort. It also uses partition methods. First, we use pivot P to split array into 2 subarrays. Then we compare the pivot with the target k. If it is k, then we just return. If not, then we can query in the subarray. In this way, for this quick select algorithm, it can achieve logN. That's much better than the previous methods. Let's see how to implement this method. There are 2 ways today I can show, and here for the first solution, we have 3 steps. First, to make this question simpler, we convert it into find the k's smallest elements. And then we get a pivot that split arrays into 2 subarrays. Last step is compare pivot and k, and if it's k, return, otherwise find in the subarray. Now let's demonstrate how it works. Let's solve this LeetCode algorithm. We convert into smallest and also input range the smallest, that is the numbers length minus k, and the starting index, that's 0, higher index, low, int high. In this private method, we want to find the k's smallest number. And using this number, we will use quick select algorithm. First, we need to do some boundary conditions. It should be equal. In this way, we get k. And for the rest, we first get a partition, and we get a pivot. And then we compare this pivot. This pivot will split the array into two parts. The first part is low to pivot minus 1, and in the middle is pivot, and then next is pivot plus 1 to high. If pivot greater than k, this means that we need to find this number in the left part from the low to pivot minus 1. Else, if pivot less than k, that will be in a larger part. Then the left condition is that pivot equals k, and we just need to return these elements. Next, we need to write partition functions. For this function, we want to use the method described in the algorithm 4. We select the pivot value as the leftmost, and then also the left right. In this method, we want to move the left pointer if it is smaller than the pivot. And if this pivot greater than high, we will break. Greater or equal, I think. Otherwise, next iteration, it will be overflow. also do the same thing for the right pointer. Sorry, should be the left. Then we need to compare left and right. And we break this circle. And at the last, if not, we need to swap left and right elements. So after this while out of the loop, it will be the data like this. First one is pivot and other elements smaller than the pivot, and then right pointer, left pointer, and other data. In this way, all the elements starting from the left pointer will be greater than the pivot. So for this problem, we need to switch between the pivot and the right pointer. That will be low and right. And at last, we return the pointer is right. Then at last, let's do the swap. Okay, let's try. Cannot find given. Oh, okay, we forgot the key. Also here we did a key. Oh, we use pivot value here. Okay. Let me show another implementation method. In this method, we don't have one pivot. In this implementation, we also compare with the first elements, which we treat it as a pivot, but we don't exchange the pivot into the middle. We only use that pivot to split the array into 2 or maybe 3 parts. If it's 2 parts, the red one is smaller than the pivot, and the green one is larger than the pivot. If it's 3 parts, in the middle, it's the same as the pivot value. If it's the same as pivot value and also is equals k, we will return that blue elements index. That's the target k. Otherwise, we will search in the subarray until we find the target key. Okay, let me demonstrate how it works. This is Tiny. Thanks for watching. See you next time.